So let's begin with some basics on linear algebra. Okay.
Okay.
So this linear algebra, why do they call this as a linear? What is linear in this linear algebra?
So linear in the sense it doesn't have higher powers.
It doesn't have higher powers. So what is the maximum power it can have?
One.
One. Okay. Uh, so basically, you're talking about a function, right?
Yes.
So so we can imagine a function like a black box. Okay, say a function f of x. Okay,
Yes.
so this is my f of x. Okay, where I will give
One.
x and I'm getting some output y.
One.
Okay, so when I give x, it will take and use it in the function, and it's giving y. Okay, now this function is a general function. It could be either linear or non-linear. When can I say linear and when can I say non-linear? I can say linear if it satisfies two properties. Remember? So what are those two properties?
One is f of x into x1 into x2 is equal to f of x1 into f of x2.
Okay.
If I give
Okay, there are two properties. Okay, so A superposition. Okay, so like say, so for this function, let me take this function. So if I give x1, okay, in this one, say I'm getting y1, and if I give x2, I'm getting y2. Okay,
yes.
then if it's a linear, or if it satisfies the superposition, then instead of giving x1 and x2 separately, if I just add x1 and x2, okay, and then together if I give, it will give some y, and if that y is y1, f of x1, which is y1 plus y2, okay,
Yes.
then we can say this function f of x satisfying superposition. Okay, that's one property, superposition. Okay, the other property, so the other property, what it is? Homogeneous,
Homogeneity.
right?
Yes.
So what it means? Okay, so once again, if I give x, it will give y. Okay, instead of x, if I give, let's say, if I give uh, if I scale the x by some alpha, okay, and then if I send it to this box, it's going to give me some y, okay, but that y is also scaled by the same alpha, okay, then this property has got satisfied. Okay, if those two properties has got satisfied, then I can say
F of x is linear.
is linear. Okay,
Yes.
okay, now what's there in what is linear in this linear algebra? Okay, so that we'll discuss. Okay, now say you have a matrix A, okay, and you multiply A on x, and say you are getting another, so say this is a column matrix,
Yes.
like a vector. Okay, and this is another vector. Okay, column matrix. Okay, now so this A, okay, acts on x is what like a so A is a one particular matrix. Okay, and you're giving x. So the way you can imagine is um, you are giving x, okay, in this equation, and then it has some a, and what it will give is a into x, which is b. Okay, now whether this operation satisfies those two properties. Okay, so what is the first property? superposition. Okay, a, say let's say I'm giving x1 and let me call that as b1. Okay, and a x2 I'm gonna get b2. Okay, now if a x1 plus x2, okay, which is equal to ax1 plus ax2, where yeah, b1 plus b2. Okay, so if I give this, I'm getting this, which is nothing but the sum of the two solutions, right? So then the superposition is working. And similarly, say I have ax is equal to b, let me scale my x by some alpha. Okay, a into alpha x equal to alpha into ax, which is equal to alpha into b. Okay, so when I scale x, the same amount, the answer is also getting scaled. Okay, so then this operation, okay,
satisfies
homogeneity as well. So in that case, this operation is linear. Okay, so therefore we call this as a linear algebra. Okay, so with that we will start.